stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello everyone and welcome to another meeting of the C++ Digital Signal Processing JUCE, Ableton Push, Raspberry Pi, HISE and various other things study group. How are you all doing?
Hey Al,
Hi.
all good.
Yeah. Okay.
So with me on the call as usual, we have Fotis and we also have Cwits.
Hey.
Hello.
And on the chat, Mage is here. Hello, what is up?
Hey mate.
I'm glad that you all are here. So,
It definitely is a mate.
so
He's like a wizard.
yep. So, how about I go first this time? How about that?
Sure.
Yeah, so I don't have a lot to show in terms of C++ or digital signal processing or JUCE, but I do have some things about electronics that I would like to share because they're kind of fun. So I thought we could talk about that just a little bit. But before I get into that, I do have some kind of bookkeeping that I want to make sure that works. So here is the thing. I finally got into the YouTube partner program, which means that in theory, I can monetize the videos. I finally reached that arbitrary goal. And
oh my God.
Yeah.
Congrats.
Congratulations.
Thank you. Thank you. But the thing is, I did not enable monetization. I got into the partner program, but I did not enable monetization. My hope is that by doing this, you will not see ads when you come to my videos. And I don't make any money either, but my hope is that you don't see ads in the videos. I tried to look into this, and what I learned is that supposedly YouTube reserves the right of putting ads on your video even if you don't monetize the video. It's just that they don't give you the money. They show the ads anyway. But as far as I could understand, they do that to videos that are not in the YouTube partner program, which is not my case anymore. And they do, of course, put ads on videos that are monetized. So what I understood from this is that if I am on the YouTube partner program and I opt out of monetization, then you don't see ads. And that's what I would like. I would like for you to not see ads. So if you do see ads, let me know. And then let's talk about electronics. So what I did this week was to play around with my oscilloscope. And here is my oscilloscope. And I'm going to show you like the very basics of what I learned because I thought it was kind of interesting. So last time I talked about this, I said that I was picking up too much noise in the signal. And I pondered if I had a different kind of probe, if that would change. And not by a whole lot. Not by a whole lot, really. So I have this new kind of probe in which I can change from 1 to 10 times attenuation, which means that if I switch it to 10 times attenuation, the signal will be attenuated by 10 times. 1 volt becomes 0.1 volts. And the previous probe I had was only at 10 times. I didn't have a 1 times option. So I thought that that could influence the results, and it does not change the results a whole lot. But anyway, now I have this kind of probe that can come in handy in the future. Another thing I did that I think helped a little, I didn't like do any scientific measurements on this, but my intuition tells me that it helped, is I read the manual and I learned that you can leave the device on for like half an hour, and then you can go into this menu, this utility menu, and do this self-adjustment thing. And then you wait for half an hour, you take out the probes, you run self-adjustment, and it makes some clicks for about 10 minutes, and then it's done. And I think that that helped a little. I think that I got a little less noise after doing that. I don't know exactly what kind of self-adjustment is actually happening in the box, but that was my experience. And I tried to measure instrument level signals and microphone level signals, and it still pick up a lot of noise, but I think it's a bit better. And I also tried headphone level signals because they're much hotter. So I learned something interesting about either the digital signal processing or more likely the digital to audio converters on my devices. I learned something about them, and I thought it would be interesting to go through my experimentation process and show you a bit of how to use the oscilloscope, or what I learned from using the oscilloscope, and that little quirk that I thought was interesting. So device number 1 is an iPad. It's too large to fit on this frame. So what I did is I plugged the iPad into a cable that is a breakout cable connected to the oscilloscope probe. And then I ran this website that is not the first, but the second result when you Google for tone generator.
Oh, this is cool. I know it.
Yeah, there are some apps even, but I found that this website was the best, particularly because I am able to run this on any device. And as we are about to see, I will run things in different operating systems. But anyway, here I am playing. Let's start with the simplest thing, a sine wave. And
nothing there.
And then I will press Alto here on the oscilloscope, and it's going to click a little bit, and I don't get any signal. God damn it.
Oh.
Auto is not always working as it's supposed. Maybe I've got a couple times also buggy auto choosing. Yes.
No, here it is. Here it is. It was just that I had to reload the tab because I had closed I had put my iPad on standby, and then I opened it again. So I had to reload the tab for it to actually produce audio. So then I can see the sine wave, and I can play around with the frequency and the volume. And it works pretty well. And here is the interesting thing for me. In this website, I can change the shape of the wave. So here I'm doing a sine wave. Now let's do a square wave. And check this transition. We see some ripples. As we would expect, we see some ripples because it is a band-limited signal. So a square wave turns into this squiggly thing, the Gibbs effect. But what is interesting to me is that for the most part, it is overshooting on the way up and on the way down, but it's not overshooting before the transition. So it's always overshooting after the transition and not before the transition. My understanding is that this digital to analog converter on the iPad is doing some band limiting, as you would expect, but it is not it's not linear phase. I would expect that most anti-aliasing filters, including the ones in digital to analog converters, to do linear phase low pass filtering for anti-aliasing. But that doesn't seem to be the case in this device.
But why transient should be why this shape should be before transient?
Oh yeah, so when you have a filter that is linear phase, the impulse response of that filter is symmetric, which means that any ripples you get after the transition, you also get them before the transition. You always see a mirror image of the signal before and after. I'm going to show you that. I'm going to show you that, in fact, because check out the second device.
Okay. I would like to see that.
Yeah, you're about to, actually. The second device is an old Thinkpad. And for the sake of completeness, it's a T430. It's about 11 years old at this point. And again, I'm not sure if this is a property of the digital to analog converter. I think it is. It may be a property of the operating system. So I am running Windows 11 on this thing, and I am running the same website, same tone generator. And this time I'm going to reload the tab before I even start. So I unplugged from the iPad, plugged into the Thinkpad, and I hit play, and I get a sine wave. Let me increase the volume and hit Auto. And what Auto does is it changes the resolution both in vertical axis, in the vertical axis where it's showing voltage, as well as in the horizontal axis where it's showing time. So it does that to try and show the signal as best as it can. And in this case, it did an excellent job, of course, as you would expect, because it's a sine wave. There is not a lot of complexity in there. So anyway, same story. I can play around with the frequency here. And let's stop about here. And now what I'm going to do is change it to a square wave. And check this out. We see ripples both before and after the transitions. Let me zoom in. Hang on. I cannot put the computer there. Let me put the computer here. Please don't fall. Okay. So let's zoom in, and I can show you what linear phase looks like. So this is what linear phase looks like. You can see that there is a bit of a overshoot before the transition as well as after the transition. And that's more in line with what I would expect.
But this one is shorter than on iPad, no?
What was that?
This one is shorter than on iPad.
You mean that the ripple is shorter?
Yes.
Oh, that may have to do with the frequency, because I was not scientific about this. I just put whatever frequency in there. Or it may be that the filter is... Well, definitely the filter is different.
It changed.
We can see that. Yeah, and I'm moving around the frequency here, and I don't think that the ripple is changing in aspect all that much. But yeah, I agree. I think that the ripple has a different characteristic. And of course, that has to do with the kind of filter that they decided to use here. But what is interesting to me is that it really does look like this is a linear phase kind of equalizer or low pass filter, as I would expect. And yeah, I guess there is less of a ripple, so perhaps the filter is also optimizing for that. Anyway, I thought that that was interesting. It was interesting to actually see stuff in the oscilloscope. Not just noise, but actual signal in the oscilloscope. And that is my update.
Nice.
I will turn off the oscilloscope now, because as you can hear, the fan is noise. Can you hear the noise of the fan?
Very faintly. Sure. Maybe not.
Well, anyway, it's off now.
Oh yeah, I did listen to a tiny bit of noise. I just turned up my headphones for a little bit. But yeah, it's gone now.
Yeah, this is an old oscilloscope, kind of cheap. So it's not the best oscilloscope.
But it's doing his work, so why not?
Yep, it is doing the work of visual. I am finally learning stuff by looking at signals in the oscilloscope, which is exactly what I wanted to do. Like this realization of minimum phase in the iPad versus linear phase on the Thinkpad, I thought was interesting, and that is exactly what I was looking for when I bought the oscilloscope. So that's why I thought it would share.
So what you're doing is basically you're comparing the DACs of both the iPad and the Thinkpad.
Yep. I think that's what I'm doing. I mean, if people who know more about this spot a mistake, then I would love to hear about it.
Nice. So can I go next?
Yes.
Yeah.
So here is my update on my success and my failures on HISE. First, I'm gonna deliver my promise to explain the thing I wanted to explain on the previous meeting. And you know, I haven't said this in the meeting before, but I was working on that XY pad and I was failing a lot. So I consulted David Healy, who is one of the developers of HISE. And just a bit after our stream ended a couple of weeks ago, David told me that my HISE project was actually working correctly. And it was very embarrassing that I didn't figure it out earlier. I could have shown it on the stream, but I'm going to show it to you guys now. And also I'm going to show you why I did it. In 1 sec, I'm gonna load the project and then I'm gonna share my screen, share computer sound. There you go. Let's turn this off. Okay, so you see my screen, you see my XY pad thingy right here. So I'm gonna turn on. So I can't move this. Oh, wait. I'm gonna change the zoom. Okay. So this is an XY pad that crossfades between two samplers. The sounds are pretty similar. I did play them 4 weeks ago, but I'm gonna play them again. So this is the sampler one. This is the second sampler. And this is the two samplers playing at once. And this is none of them. No sampler. So the sounds are very similar, but this one has a slower attack and more robust sound. While this has a sharper attack, but it sounds a bit thinner. So when played together, they create a more interesting result. And yes, I added a bit of shimmer reverb. And of course, I used, on the top left, I used Leandro's Vicanic implementation. And on the bottom right, I used Bose EMA filters. So yeah. And as you may remember, I recorded both of these from a Yamaha keyboard, the output of its speaker, to be precise, while my students were playing in the background. And I'm gonna explain why. Hey, I now have a study group bookmarks folder, so now I can show you exactly what I want. The first time I read about this technique was on an Aphex Twin interview. So this is this technique when you play a sample and you play it back and you record it again. He calls it reamping. You take sounds, you stick them through a speaker or guitar cabinet and record it again. Then it's been in the real world and put back into the computer. It's a nice thing to do. And another way they call this is quite weird. It's called worldizing. It's the same technique but with a different name. Walter Murch did it, and he's a sound designer, and I think he was also an editor for Francis Ford Coppola's greatest films. But they used this technique in order to fix the sound mix on a movie that was actually directed by the musician Neil Young. It's called Human Highway. I haven't seen it, but this worldizing So what they did was the same thing. They played the audio back in an acoustic space and re-recorded it. And this is how they beefed up the sound mix of the movie for the reissue. This is the remastered version.
I
of
heard
the
something
movie.
interesting related to this in the mastering show podcast with Ian Shepard and John Tidy from the Reaper blog. They were talking about, I don't remember if John Tidy was on that episode, but in any case, they were talking about spatial audio, and one thing that many people are doing to get the Atmos mix is just play the stereo mix in an environment and put microphones around.
Oh yeah, this has been done before. This is an ultra nerdy reference that I'm gonna make. Only 2 people will get it. But there was like 20 years, 15 years ago, there was back when DTS was making those DVDs. They had created one that was called Studio Voodoo. It was like a techno compilation mixed in DTS ES 6.1 discrete. And it also had a binaural mix with one of those Neumann microphones that are head-shaped, you know, that they record the audio from their ears. And what they did was just place that head-shaped microphone in a room full of speakers, and they let it listen to the recording. So they recorded off of that. Yeah. And another example I'm gonna show here. Can you please show my screen again? Yes. This is from an interview with Brian Eno. And he talks about one of his students called Fred again. And he says he's often recording on his phone in quite noisy places. And he doesn't clean everything off. So in every piece of recording, there's a sort of context that comes with it as well. The sound has a history built into it. So this is why I did all this. Oh, and speaking of Ian Shepard, did you know that I collaborated with him on one of his videos a long time ago?
I did not know that.
Okay, I'm gonna show you guys later. I'm gonna share it in the chat once my segment is over. Now I wanna show my other project that I did today. Sorry. This time I'm gonna show another sort of failed but kind of worked around HISE experiment. So as you know, the implementation of FAUST in HISE is still not very complete, especially in the instrument front. There is a nice instrument called harpsichord. It's a plain words on carpal strung and harpsichord. And I could make it work kind of sort of in HISE, but it was very finicky because I couldn't map it to the MIDI keyboard. I had to create a gate and then a knob that chooses the specific frequency, which is a pain. So what I did instead was I used the online FAUST IDE. I'm gonna show it in Firefox because I had problems with it in Chrome. And maybe I will have trouble now, but I'm gonna try different. Sorry. So yeah, this is the online version of FAUST block.
Oh, that's very cool.
Yeah, and I apologize to a FAUST developer, Sleds, who is in Discord because I bombarded him with messages earlier. I couldn't make something work. Sorry. Anyway, so you press run, and you have this. You have this thing. You can compile it. You can also export it in when you press here. Unfortunately, this is not. This didn't work for me. I tried to do the VSTI compile, but then I loaded it, the resulting DLL file into Reaper, and it crashed. So yeah, I am playing the harpsichord.
In
with
theory,
my
that would
computer
have been
keyboard.
very cool to be able to compile a VST in the browser.
Yeah. I informed
Totally.
Sledge about this. I informed Sledge about this, and he said he's gonna look into it. So anyway, you also have an audio recorder here. So you can press record, and then you save the resulting thing to a WAV file. And I did this, so I made two recordings of the C note.
Oh, so you're going to sample the FAUST thing. I thought you were going to try and make it compatible with HISE and run FAUST in there.
Yeah, I tried it, but I used it. I did use it in HISE, but as an effect, like I did the last time.
I see.
But I'm gonna show you something a bit more interesting than the thing I did last time. So these are two exports from FAUST. I did the second a bit quieter in Reaper because I wanted to make a fake round robin. So this is the sampler. Also, I learned how to make round robins. Yay! So what you do is that you place the two samples you want to be in round robin in the same area. Both of them have to occupy exactly the same mapping. Then you go to this workspace, go to sampler settings, and you press and you input a number according to how many round robins you want to have. The more the samples, the more the groups. And then you choose the group in here. So this is how you do it. How you do a sequential round robin. If you want to do a random round robin, you can check out David Healy's YouTube. He has made a script about it. Anyway, so let's go back to some FAUST madness. Let's close this and let's go to the script effects. So this is I made a lot of attempts to, so this is how the harpsichord works inside the HISE. It does disable the sampler, so you can't play. But you can technically play by using this gate. So you use a frequency. So theoretically, if I can map those knobs to some parameters and create something cool in GUI, but come on, do you really want to make a parameter for each bunch of hertz? So I said I wanted to implement some guitar distortion, but I failed because they had not some dependencies. I didn't have all the dependencies, but I kept running into trouble. Sometimes I had difficulties in the input channels. This still hasn't been implemented in HISE. But what I did instead was, if you want to check out what cool things have been made in FAUST, and many of these are open source, and this is what I did. You can go to this sub page in the FAUST website that's called Powered by FAUST. And it's a huge list of VSTs, software, apps, and even websites that utilize FAUST to some extent. And hey, there's HISE as well. And what I ended up using was Reverb Zen, which is, come on, take me there, yes. So you can actually download it as a VST3 on the GitHub, but I prefer to just get the FAUST file, you know, that's more fun. Anyway, so let's go to the reverb.
And that whole project was a single DSP file?
No, actually that VST was created in JUCE. The GUI and all of that was built in JUCE.
Yeah, but you clicked on one file. You clicked on a link for one file that was a .dsp file, and was that the whole implementation of the reverb?
Yeah, that was it.
Oh, let's look at it.
That's how FAUST works. Yes, sorry, I'm gonna do it.
Handy.
Actually, I'm gonna load it in my notepad so I can zoom in the code.
Yeah, I know that in FAUST you have all these libraries, and you could, I guess, implement an effect using multiple files and make things more structured. But if it is using a single file, then we have to look at it. I guess it's a big file, but still.
Yeah. Yeah, it's not very big. It's only like less than.
Oh, it's not a big file. I thought that the number showing the file size was in kilobytes, and it was in bytes.
How it is
it's in bytes, yeah. And it uses only one library, the standard FAUST. 1 second, I'm gonna play. Do you want to look at the code first and then listen how it sounds like? So
it's up to you. We can listen first.
Okay. So yeah, it's gonna be a little bit quiet. Oh yeah, I didn't save the settings. Sorry about that. Forgot. So you have to turn down the width because of the limitations. The pre-delay is a bit long. And you have the decay. I'm gonna make it a bit more. You have the low pass. This is a bit interesting. I've never seen this before in a plugin. The mix high pass in and mix high pass out. They only have 2 values. So if you turn on this, you have a high pass on both the input and the output. But if you do the opposite, now we only have a high pass in the input, and now we have no high pass at all. Sorry about the sudden bass boost. Now you notice that once I have both of these turned off, the high pass cutoff didn't work at all because I turned it off completely.
As far as reverbs go, this one does not sound awesome to my ears. Sounds very metallic.
Yeah, it's one of the reasons is the sample itself. But yeah, you're right. Maybe I can do something better with.
Well, I guess it is just the nature of the Schroeder. I think the Schroeder reverberators.
Yeah,
they don't sound too awesome. They were nice for what they were at the time when they were created, but they're not the best.
Yeah, maybe it sounds better in the plugin implementation. I don't know.
I don't think so, because it's going to be powered by the same DSP file, right?
Yeah.
Yeah, just the nature of the theory, that the digital signal processing theory that goes into making this just does not lend itself to great sounding reverbs. There is a whole story about how they were developed, and it's a fascinating story. The person from Valhalla that does great reverbs talks about this in a lecture and a podcast. I guess in particular, I would refer people to the podcast. It's by Why We Bleep, I think. And there is an interview with Sean Costello, I think is his name, from Valhalla. And he explains this whole history behind this reverberator and this algorithm. And it was developed way back when we did not have such a fast feedback loop to test things and hear things. And of course, we didn't have as much computational power. So for what it was back then, it sounded okay. But it's not the best sounding reverb. But anyway, looking at the code will be interesting anyhow. It seems like there are a couple of filters and some delay lines. The delay lines are right here behind my face.
Yeah.
And
tell me if you want me to scroll.
Yeah, I'm just seeing the primitives. I guess the delay lines and the filter implementations come from the default standard library. And then I suppose that it is just selecting a bunch of cutoff frequencies. That's what we see on this block.
Yeah, it's the damping, I think. No, it's the low pass.
I really like something about the way that this code reads. It's a language feature that we don't see often and that I like. And that is, it has a formula in line 10, And then it has this block between line 11 and 20 that is defining some variables for the equation. And in many cases, when we are explaining a concept, we go from bottom up. So we go from this is FC1, FC2, and so on. Depending on how you explain things and on what you are explaining, it makes sense to go bottom up. So you explain first the FC1 to 8, and then finally you'll put everything together in the equation. And that's what often we do in code. We often go from bottom up. We define all the auxiliary functions, and then we define the big function that uses all the auxiliary functions. We define all the little variables, and then we combine the variables in a formula. But depending on what you're doing, I think it's nice to have the option to define things top-down. So you first define the big thing, and then people can look at it, and it can sink in, and you can see the structure of how the pieces are going to be put together. And then, if you're interested, you can dive into the pieces and how they are defined. I guess this is a perfect example of that, where you just look at line 10 and you see it's a bunch of low-pass filters. If you're interested in knowing the cutoff frequencies, then you dive into the lines below. And it is very rare that programming languages allow you to define these things in this top-down manner. I can think of Haskell, Pirate, and I guess FAUST now. Those are the only ones that spring to mind. Maybe some flavors of Lisp will allow you to do that with macros, of course. But yeah, I wanted to bring this up because I think it's a very interesting architectural organizational decision.
And we have a similar structure.
And then a bunch of comp filters.
Yeah, the all pass, yeah.
Yeah.
Maybe that's the reason why it sounds so metallic, the comp filter.
Yeah, and the tricky thing is in the tuning of all this, is in finding the coefficients that will make sense for the comp filter, finding the cutoff frequencies of the filters, finding the length of the delay lines. Fine-tuning these parameters is what could make the reverb sound slightly better, but it is difficult to do.
And then you have these things. These are the parameters.
Yeah.
The sliders, yeah. And then you have the mixing. These are the wires, like we saw last time. Like the mono becomes stereo here, and then it becomes mono again. Like a dual mono.
FAUST looks so minimalistic.
Yeah. And this is the final processing. I think when all of it comes together.
Oh, I suppose that X and Y are left and right?
Yeah, I think so. Maybe it's defined here. No, it's not. I don't see any.
I guess it is defined there, right? Because that is a definition.
Yeah.
The last line in the program is a definition. So process will receive 2 arguments, and you're giving the arguments names, and the person decided to give the arguments the names of X and Y. So it is the definition. And in this case, I suppose it's left and right. And then it is just taking the left and right, taking the average of them, which means that if they're out of phase, they're going to cancel out. But then X and Y appear again, and they're subtracted from one another. So if they're out of phase, they don't cancel out in that case. Interesting. And then it is splitting the signal with that less than column operator, and then doing a high pass, a bunch of high passes, then doing the matrix, and then passing the signal through the delays, the comp filters, some feedback stuff. Yeah, not all of this makes sense, but some of it does.
Yeah. So that's about what I managed to do. I did do a lot of stupid things with the FAUST IDE that consumed a lot of my time. So I think, and also a lot of stupid things with these. So, like this. Beautiful, right?
Yeah.
So yeah. So I just loaded this reverb and then I gave up. because I wanted to take a breather. And finally, I wanted to talk to you guys about something that's HISE related again. But believe it or not, I'm gonna need help in making something in C++. Dun dun dun! What? So yeah, here's a little story. I had a little conversation with David Healy, one of the developers. The main developer is Christoph Hart, of course. That's where the name comes from, the H in HISE. But I was talking to David, and I was talking about the possible implementation of Air Windows in HISE, a topic which has been done before, but I didn't want to necropost. I made a new thread. I talked to David in Patreon, and he noticed something weird in the Air Windows repository. So let's go to the main one. Yes. So you can see that the repo was in MIT license, but if you went to the plugins, at least before the latest commit, let's go here. You would notice that the code read Air Windows all rights reserved, which is not compatible with MIT. So I sent Chris an email about this. And you know, Chris has been having some life issues lately. Some people very dear to him have been having some health issues, and also he had a few cough issues, but I think he's okay now. So yeah, he's been having a rough patch, and he still took some time to help me out. So this is how amazing Chris is as a person. And I'm not gonna click this because it's gonna load 3,000 changes. But he actually went and searched and replaced all of the instances of all rights reserved to Air Windows uses the MIT license. And he told me that you're welcome to use the code in any way you like. And yes, I told him about HISE and he's on board. Yeah. Now here's the trick.
So Fotis, something about this. Yes. First of all, I'm not a lawyer.
Yes.
But my understanding is that you do have to say that all the rights are yours. You are the developer of the thing. You have to claim all the rights to be yours and license those rights for other people. So you have the rights, it's your code, you claim the code, and only because the code is your property that you can release it as something that is open source. So if you read like the license for the MIT license, if you read the text of the license, if you go to their website and look at it, then you will see that the first line is you claiming the copyright to that thing. And then you say permission is granted for other people to do these things, copy, modify, merge, publish, distribute, sublicense, and so on. So you first have to claim the rights so that you are effectively, you have the right to give to someone. If you can only give to someone something that you have to begin with. So I think that clarifying that on the header in every file is probably a good idea as well. But I think that by the presence of that file at the top level of the repository, as well as this, which is just my understanding, if you all know better, correct me. But I think that the thing he used to have was good enough. But I think it may be even better now. But I think it was good enough.
Okay. Anyway, I'm gonna talk to Dave. Probably David is gonna watch this stream. I'm gonna show the link, and maybe he can reply. Anyway, so as usual Fotis stuff, I begged to people to help me. So I needed some help on how to create those Air Windows, because I do have some ideas, not only to create some air windows with GUIs, but also to create instruments and synths that implement air windows in some fashion, like the air windows distortion or some things like that. Because I know air windows like the palm of my hand, and I know what sounds I get out of them. So, and you know that Surge XT does have air windows built inside them. And I want to do something similar. Unfortunately, my thread was not met with much enthusiasm because Christoph Hart is not a fan of air windows, sadly. But Dan says that I can use the script node. I forgot what the EX was. Let me see it again, sorry. In the docs. So it's, script node expression language. It's a simplified subset of the C language family and is used throughout script node for customization behavior. So theoretically, I could do it somehow. You can grab the variables from the H file of the air windows. The default values are in CPP and the function is in proc.cpp. And Christoph says that he actually wrote a VST2 node wrapper. You could drop vanilla VST2 codes in the third-party folder. He reverse engineered the API calls. And it worked with most of the air windows effects, but then he lost the file because it was deleted. Oopsie. Just in case anyone was wondering why it gives reference to the third-party folder now. So yeah, maybe this could be, if I learn how to do this, how to use SNX, maybe theoretically I could create some air windows ports, right?
You could also try and write them the same way that you learned how to write them in JS Effects. You could learn how to write them using the HISE script language.
Yeah, I could do that as well. Yeah, I could use some script, and that would be a bit more flexible. Yeah, that's a good idea, actually. I didn't think about that. So yeah, and besides, I have begun learning the very basics of HISE scripting. So it should be more interesting and more educational if I actually learned how to do it in a HISE script instead of using this, right? Because I would learn how the code works and how it can be transferred.
Or at least you're going to learn a thing or two about transforming syntax.
Yeah. So that's about it about my update. And for the next time, I'm gonna try, I'm gonna stop sharing. And for the next time, I'm gonna try implementing those guitar distortion things that I wanted to use in this harpsichord, and instead I used that metallic Schroeder reverb.
Yeah.
Those distortions were taken from a Linux-based LV2 plugin called Guitarix. I don't know if you've heard about it. It's an open source thing like Amplitude or Guitarig. And the problem is that HISE is still finicky depending on the input and output channels of FAUST scripts. And I tried removing those greater than, less than, and semicolons and colons and stuff, and I only succeeded in destroying the script, the DSP file. I destroyed it. So I'm gonna do some more trial and errors until I get it right, or at least until the FAUST code is a bit better implemented in the near future. Please.
Yeah, well, about the sound of the reverb, we have some input here from Jas. So hello, great to have you here.
Hey, Jas.
And what they say is that this kind of reverb can sound good as long as you tune it correctly. Oh, yeah. You have to be careful with sound design while using it. It's specific. It is just a bunch of comb filters and some all passes, so just some delay lines. but you can do stuff like modulation, which I guess that implementation was not doing, and I think that the original implementation does not do. And then you can remove some of the metallicness.
Oh yeah, Disco DSP, I think I used that one. I think it's freeware. Disco DSP is the same person who made the Oberheim synthesizer called OBXD, and also the Discovery, which is, I forget what synth it's supposed to emulate. But yeah, those filters from the Oberheim synth that came from the OBXD, I think those were the same filters that I used in the previous meeting, those Oberheim low passes, if you remember, in the HISE.
Yeah, and Jazz is saying that you should be using C++ and JUCE.
Oh, hey, Cool Wav is here. I didn't expect that. I know this person. He creates some nice presets for synths and stuff. So, hey, Cool Wav.
Right. So, yeah, but you were saying... I feel like I interrupted you. Do you have more things that you want to do for next time?
No, it's just this... I'm going to implement those guitar distortions in a harpsichord. And also I'm going to try to create something that blends between them, because they have... I think that's... I also found one that also didn't work, that had 3 different DSP files: the distortion one, the preamp one, and the post-amp one. I don't know what they do, but I'm gonna test them out and see what they do. And then I'm gonna create some faders so you can blend in the parameters and you can pick your favorite distortion out of this. It should be fun, right?
Oh, cool.
Yeah.
Oh yeah, Discovery, Nord lead emulation. Yeah, that's right.
All right. So next we have Cwits, and before we started the meeting, Cwits said that he didn't have much to share. Oh, but he did have one thing to share.
Totally.
He did work on one thing, and I bet that now he's going to come in and steal this show and show us a bunch of interesting things.
I have worked on something. What? I missed something, Leandro?
Your voice is much clearer. Did you get a new mic?
No, just I'm handling microphone near my mouth.
Okay.
No, to be honest, I done nothing interesting and showable. Just couple minor things, which I don't remember what I've done there because I don't using notes. Maybe I have to, but it's a lot of extra work. Leandro, how do you handle it? So
yeah, I take notes.
how? Teach me, please.
The best thing you can do for yourself is have a notepad. And I don't mean an app, I don't mean a phone, I just mean a pen and paper. Or at least it works very well for me.
5 notepads in a paper format and bunch of pens around me, but I'm not using them.
Different strokes. But yeah, so do you know what you want to work on next? Do you have maybe too many ideas to work on, or maybe too few? Because if you have too few, I can definitely suggest some things.
For approximately 1 week ago, I realized that my project is growing too big and I need to separate things somehow. I don't know how to be able to work on things separately, because recompiling, when you change one line of the code, it recompiles almost whole project, and it's not about takes much time, but still it's a little bit annoying when you're experimenting and changed one variable then you don't like the result, then you change it again, and again recompiling the almost whole project. It's getting a little bit, how to say that? I don't know that word in English. Okay, annoying, but there is another word for that. So yeah, I will try to separate the Ableton push thing from my whole project and maybe to work on it somehow differently.
Is it going to be a library that you'll link into the project, or is it going to be a standalone process?
It's difficult question for now. One problem that I met is that from the one side, the code should be how it's called. Weak tired between itself. It's a good practice when you have less connection between those modules you're writing. Yes, for example, push and back audio back and then GUI stuff and. But I've got them tied together pretty hard, and this causing these kind of problems.
Oh.
With recompiling things and yeah. So to be actually, I don't know what to do with it. From the one hand, it should be like how do I say that? Less connected together, but from the other hand, it should be connected a lot together because there is a lot of small information that have to be carried between those modules.
The age-old question of whether you let things be, I guess, solving all the problems in one place or trying to find abstractions and separate the solutions for smaller problems in different places and let the smaller solutions talk to one another. So
yeah, kind of, but also I don't want to overcomplicate code because I have only Raspberry Pi and I want to stay in that format. And
well, I gotta say, I am a big fan of coupled code where everything is in one place, because I said this 1,000 times in my streams and I'm gonna say it the 1,001st time. I think that having the wrong abstraction is worse than having no abstraction. And I didn't make this up, of course. I first heard it from Sandy Metz, and I'm not even sure if she was the first to say it. But having the wrong abstraction is much worse than having no abstraction at all. So I'm a fan of having everything as one tangled mess, a beautiful spaghetti. And then later you can start to find the abstractions and find the separation. So maybe you are at that breaker point where you're starting to get annoyed by the spaghetti and you want to untangle things and decouple some things. But I think that this is the right way of doing things. If you start to get annoyed by something, you go and fix it. If that serves as encouragement.
Yeah, I agree. You, at least for now, I totally agree. You, but that's fair. Yeah, I'm struggling with something. I don't know what I'm struggling for. So yeah, I have nothing to show, just for a little bit talk and then watch you guys.
Sounds good. Actually,
you did some studying, you did some theory. That's still important.
No, I done nothing, as I've said.
Well, at least now you learned about the fact that a linear phase equalizer, when you look at the impulse response of it, it is symmetric. So you learned something.
Oh yeah, about that, is only square wave have that behavior?
No. So it is the impulse response of the filter itself. And in the square wave, it is easier to see because there is that sharp edge.
Okay.
And then you can sort of see the impulse response there. I guess it would be even better if I had just one impulse and then we would see the impulse response. But of course, it doesn't translate all that well when doing analog, I don't think. In any case, the square wave helps you see that sharp transition and helps you see the shape of the filter, but that is a property that exists when you're filtering any kind of signal. The impulse response of that filter is symmetric if it is linear phase, and vice versa, incidentally. If it is symmetric, it is linear phase, and if it is linear phase, it is going to be symmetric. It's a bidirectional relationship, and it is something that occurs throughout the signal. It's just that looking at the square wave, or we were not really looking at the square wave, if we were looking at just a step, helps you see that kind of thing.
Yeah.
Oh, by the way, I just remembered something that I entertained the thought of doing about the Air Windows porting. Some sort of. I wanted to do something fun, and maybe I'll do it next time. I wanted to capture impulse responses of the Air Windows reverbs, because recently that RIA script that allows you to capture impulse response of your Reaper effects chain. Have you seen that thing?
No.
Did you know that that thing existed?
No.
Hang on a second. I'm gonna tell you where it is. Yeah, that is a thing. So there's one more thing that you learned today. Let's go to action list. IR effects chain IR. Oh yeah, so it's by Amagalma scripts. You can get it from Repack, and you can create an impulse response of the effects chain of the selected track. And that's like, it works, and it actually had some bug fixes lately regarding linear phase filters. So it should be, until I figure out how to actually port the Air Windows code in HISE, I can just do the stupid way of creating impulse responses and loading them in HISE's convolver. That should be a good first step, just to create mock-ups of what I really want to do with Air Windows before I actually port the code inside.
You do realize that does not work 100%, right?
Of course, yeah. And besides, those Air Windows reverbs are algorithmic. They don't, and the filters, some of the Air Windows filters are non-linear, and that's not going to be 100% captured by an impulse response, because what you're doing is essentially freezing time, right?
Yeah, that's what I was thinking. It comes back to the thing we were talking about. To make the reverb sound better, we want to modulate things. Depending on the underlying theory you're using to develop the reverb in the first place. But for most algorithmic reverbs, you will want to modulate something, and that modulation will be lost when you take the impulse response.
I know. That's why I call it stupid in the first place. But it should be good for a nice first try. And I don't know. Oh, and also in the HISE used today is a nightly. Again, it released just a few hours ago, and I built it today. And it's a bit later after HISE version 3.0.1, which was released yesterday. And they fixed a bug that occurred when you were trying to export a multi-channel plugin with the standalone version. So technically, I could be making some multi-channel algorithmic reverbs. That would be a nice goal.
Nice. All right. So with that, are we good to wrap up?
Sure.
All right. So
Cwits, you want to say?
What?
Cwits, would you like to add something else?
No.
Oh, okay.
Thank you. It's
Okay.
all.
So before we go, I do want to share what I have coming up. Tomorrow, I was supposed to work on one of my long-standing projects, either the Auto Mixer or Kill the Newsletter, but I thought, you know what we need? We need another project to work on. So I had this idea for a small project that I think is going to be fun, and I'm going to start it tomorrow. And that has to do with what we did yesterday over at IDDQD Sound, Aria's channel.
Oh.
We were playing with data bending, which is the process of taking a file of one media type, like a video, and interpreting the bits that make up that file as if they were something else. So you take the bits that make up a video file and you interpret those bits as if they were audio and apply an audio effect to it, like a reverb. And then you look at the results in the video format. And we were playing around yesterday and in previous streams over at IDDQD Sound. And we learned that some things work well, some things don't work very well. I ended up creating this cookbook, this cheat sheet of commands that you can use to transform files and whatnot. And I started to work on a video about this. Fotis even talked about this in Discord or maybe on the YouTube chat that you wanted to have access to these commands. But I started working on this YouTube short about this, but I wasn't so happy with just describing a bunch of commands on a YouTube short. So what I decided to do instead, and that's what we are going to start working on tomorrow, is to have a program that encapsulates all this knowledge. So you drop a file into the program and it is going to pick a bunch of data bands for you. You may have little control over the data bands. I think that's kind of part of the fun. So it will randomize, like it will put a tremolo and it will put a reverb and it will put a high pass filter and it will throw just a bunch of those, try many variations and give you all these variations, and then you can look at them, see if you like them. Maybe you can tweak the command just a little bit and get something better out of it. So it's kind of like the juxtaposition of the thing we were working on yesterday with the latest video on the Reaper blog channel. Yeah. He was talking about that randomizer for VSCs that exists in Reaper. So I thought, that would be kind of interesting if we could randomize data bands.
It's exciting.
Yeah.
Bo just joined.
Hey, Bo.
Hey, guys. How you doing?
Good.
What you been up to? What did I miss?
Well, I'm just describing this new project I'm going to start tomorrow. It has to do with data bending. I'm going to create a little script that data bends files in various ways, kind of random ways. And I'm even thinking of doing the opposite. You throw some audio in the thing and it's going to convert that into video and process that with some video processing algorithms like Blur, and then output the audio back. And yeah, I'm going to start working on this tomorrow. And on Friday, so I'm sharing my schedule for the next days. On Friday, I do have a very special guest coming into the stream, Saurin, who is has been the director of the Triforce Percent speedrun. Are you all into speedrunning? Or watching speedruns?
I haven't even watched it, sorry.
My brother watches a lot of speedruns.
Speedrunning the code.
I think he has done a few as well.
Awesome.
I was actually...
The game's done quick.
Okay. So you're coding games like really... You're speed coding or what?
No. So yeah, speed running is when you take a game and you play it as fast as possible.
Okay.
And that's something that humans sometimes do. I guess most speedruns are humans who are running. But you can also program a computer to run. So a computer is going to be pressing buttons on the controller, and a computer can press buttons on the controller really fast. And that's what's called a tool-assisted speedrun. And then there is this old game called The Legend of Zelda: Ocarina of Time. It's from the N64 by Nintendo. It was released in 1998. And recently, about 2.5, 3 years ago, people found a groundbreaking glitch in the game that allows you to inject arbitrary code. Effectively, they kind of found a way to hack the computer program that is the game. So that is the most devastating security breach you can find in an application. You can run arbitrary code in the application, and that's what happened. So now there is a way for you to program a computer to pretend that it is pressing buttons on the controller, and you can trick the program, the game, to interpret the inputs from the controller as if that was code. And that allows you to just run arbitrary code in the console. So what they did, it was a big team of 25 people working over 2.5 years. But what they did is they created a different experience in the game with new scenarios, new characters, new boss fights, a whole different timeline.
Really?
And they connected the N64 to the internet and got Twitch messages from the chat in real time. It was like a mind-blowing demonstration of technical ability as well as a beautiful story. I mean, it is really amazing what they did there. And then Sorin, who was the director of this whole thing, he was directing the 25 people who were working on this, from voice actors to people who do the story, who write the lines that the characters say. He was directing the whole thing. He will be joining us on Friday.
Cool.
And
nice.
There are plenty of videos about what was it exactly that they did. Like, this is how the security breach occurred in the game and how you can explore it. There are videos that explain that. There is even some videos by Sorin himself in which he explains all the things that were already in the game and things that they created and how everything was put together. But on Friday, we are going to get, of course, it's me. We are going to get down to the technical details that he didn't get a chance to talk about in other places because they were trying to be more accessible to the general public. But on Friday, we will be talking first about the music production side of things, because besides being the director and the main programmer, he was also the person who arranged most of the original songs in that speedrun.
Oh.
And he used Reaper,
right.
incidentally. He used Reaper to arrange all but one of the songs. And so we will learn about how to arrange for the N64, how to converge things so that they can be played in-game, how to inject all that using controller inputs, and then get into the code for the boss fight, cell shading. At the end of the speedrun, they do cell shading, which is this other technique for 3D rendering that looks cartoonish. And so it looks like the Breath of the Wild Zelda
Wind
game.
Waker. And the Wind Waker.
Yeah.
I have done a few things about hacking Nintendo 64 music, so I can join. And also in the chat. And also I just posted in the Skype chat the video I did with Ian Shepherd. I don't appear in the video itself, but I sent him some stuff and he mentions me in the video, so you can check out what we did.
I'll put that in the notes for the meeting.
Yes.
But
Awesome.
yeah, so coming up this Friday, we have this conversation with Sorin. I'm really looking forward to that. I think it will be a lot of fun. And then, yeah, so tomorrow, data bending with a script. And I have big plans for this to be something that is easy to use, so you don't have to learn about FFmpeg or the command line. I think we will be able to package this using Cache, and it will be easy to use. So people don't have to learn about the command line. They can just drop a file somewhere and see if they like the data bending that comes out. And then on Friday...
There's a whole community.
Yeah, and then on Friday...
There's a whole community about data bending, yes.
Yeah, so sorry, what was that?
There's a whole community about data bending, data moshing that will be interested in this tool.
Yeah, I hope so. I couldn't find anything exactly like what I think we are going to be building. So, yeah, and then on Monday we may resume the regular schedule with JS effects. We'll see. We'll see. Stay tuned.
Cool. Looking forward to it.
Yeah.
It sounds like
Bo, can you give us like a quick update? Because we are about to wrap up, but I would love to hear just the highlights from your 2 weeks.
It's going to be a quick one. Share screen. No, that was the chat. Start sharing. You see my Reaper now?
Yes.
Yeah.
Oh, cool. So I've been updating my compressor, and I've included the different varieties or the different flavors of compression. So this one, they're not working as smoothly as I'd like. Should I play some examples?
Yes.
Sure.
So these are drums, and hang on.
We can't hear it.
Yeah, we don't hear any of that. I think that maybe you're not sharing your computer audio on Skype.
How do I do that? Is it ASU driver or?
When you share screen on Skype, it gives you a switch that says share computer sound.
Oh, really? On macOS, you have to jump through so many hoops to get that. On Windows, they just give you. Well, I guess that makes sense because they're in control of Windows and Skype and everything. So it makes sense.
Share. Now that I may have to stop sharing.
You have to stop and then play it again.
Okay. Stop sharing. Confirm. Stop sharing. Share screen. Share computer sound. There you go. Thank you, Fotis. Audible now?
Yeah.
Yep.
So the different flavors, this would be a sort of leveling thingy. This is the low cut. I can put some more, stick a low cut. And this will grab the peaks way more.
Nice.
And this is the sort of the hyper, so this will grab the peaks even further. So this is the delta signal. There's a bit of sort of fuzziness to the delta signal. I'm not sure why this is. I'm gonna tweak the algorithms a bit further. But what bugs me though is that this sounds really crappy, this thing.
Why does that bug you?
I don't like the sound of this.
But have you ran other compressors and did the delta? Because I did that, and even good sounding compressors will do that kind of on the delta signal.
Yeah, I know. Yeah, I don't like it. I need to look further into this. Maybe it is okay. I don't know. But this is the one of the flavors.
Maybe it's because of the harmonics being applied and you're hearing the difference.
Yeah, I'm thinking that too. I think the compressor sort of kicks in too quickly, so it's producing overtones. It's making sorry, my English is not my first language. Anyways, it's producing, it's distorting, it's aliasing, simple as that.
So
yeah,
there are different kinds of distortions. If the aliasing is the problem, you can just oversample the plugin and then the aliasing will be gone. But if you have other kinds of distortion, harmonic distortion, then of course oversampling will not help with that. But maybe that is desirable. Some harmonic distortion may be desirable.
I guess it could cut through a bit. I need to work further on this and maybe decide if it's an issue or not. If you don't see it, maybe it's just me seeing it as an issue.
I guess in summary, I will not get too hung up into what the delta sounds like. But yeah, if you want to get rid of aliasing, oversampling, if you want to get rid of some of the harmonic distortion because you're just crushing the signal too fast, then JUCE, of course, has the answer for you here in the chat. And that makes a lot of sense. Just slow attack, then you are not hitting the signal so fast, or use some look ahead so that you start smashing the signal before the transient, and that should alleviate some of the distortion as well.
All right. Yeah, I need to thank you, Jazz. I need to tweak this further. And like you said, I need to audition a couple of other compressors, because like you said, I recognize this the delta signal sounding like this on compressors. So, but this sounds cool though, so I'm happy with that.
Yeah, it is inflating the room.
And if I do a bit of a low cut, it's going to sound
nice. It has a certain character to it.
Yes, definitely. And I've also been working on the that split split thingy. And to that I've added, so this is the regular split band thingy. And
I love how you named it.
Oh, cool. And this would be the delta signal for it. So now it's only distorting the lower bit. I could push it a bit harder. And this is further up in the register. Oh, sorry. And there's also a low cut version where the distorted signal cuts away at the base.
Nice.
But I'm not super happy with the distortion. So I was thinking of doing a different, not doing the 10H, or maybe doing an option for using the 10H or another one. And this is the algorithm that Windows Chris uses for his Mojo. It's a relatively simple sine distortion. I was hoping that I could finish this today, but I didn't have the time for it. But I'm going to include that and see if it makes a difference. Because the sine distortion folds in on itself. Can you see my Desmos now?
No, we just see Reaper. I think you're sharing a window and not the whole desktop.
Choose confirm stop sharing.
Yeah, you need to check the one that says share computer screen.
Can you see it now?
Oh yeah, there it is.
Yep. So this would be, so the 10H looks like this, and the sine would look like this. So if I push it, it's going to fold in on itself. So it's going to produce possibly a more radical and maybe more harmonic distortion. I'm not sure. I'm going to try it. And maybe look up some other distortion algorithms, because it's a bit too harsh sounding for my taste.
It is, I think, what is called negative compression. When the louder the original signal gets, the quieter the output gets. I think that's called negative compression or a negative ratio, because the more you increase the ratio, the more you get a flat line in terms of the curve of the input and output, the response curve. But when you start diving back down in that response curve, you are going beyond infinity and you wrap back to negative, I guess.
Yeah.
Oh, this is it reminds me of something that Chris from Air Windows said about inverse dynamics in the Vary-Mu style compression. The one you said that you get the flatter curve, you make the louder comes into -1.
Yeah, it folds. Folding distortion. It folds in on itself. But I'm going to try a couple of different distortion algorithms. So that's
right. You're talking about wave shaping. Everything I said was about compression because I was still thinking about the compressor you showed.
Yeah,
but you're doing wave shaping. That's a different story. Yeah, if you do that kind of shape when you're wave shaping, you will just change the signal in a different way. And JUCE is mentioning here that if you don't clamp, it's going to change the frequencies too, which I guess makes sense because if you're making the wave fold into itself, a sine wave will kind of come up and back down and back up faster. So it's going to add some higher frequencies, I suppose.
Yep. You're going to get the first and third, is it first and second overtone distortion for a regular sine wave? It's going to look more like a, well, every distortion kind of does that, but it's going to take the shape of a square wave. Sort of go that way. Yep. Sorry, Fotis.
Quick question. Do you remember what the Air Windows wave shaper was called?
He has a bunch of wave shapers.
Yeah, but the first one was called fracture.
Okay.
That's the simplest one of them all. It's doing the most basic wave folding thing.
So it's a regular sort of sine distortion, or all right, cool. Because I think the Mojo has a bit. It doesn't. It folds in a bit differently.
Yeah, it was more sophisticated kind. I really like it.
Yeah, it sounds really good. So that's what I've been up to.
Nice. Do you know what you want to do for next meeting besides the things you mentioned?
Yeah, I've been thinking of a different kind of distortion thingy. So one idea that I have is, when you take any positive value and split it up, and then use like any value above 0, you set that to 1, and any value below 0, you set that to 1. And maybe do a filter thing on that, maybe split it up so that you get different sections. So a value above 0.1 gets to be 0.5, and anything above, I'm thinking of doing sort of a staircase distortion. So if you feed it a sine wave, it would sort of look at a staircased square wave.
A bit crushed.
Square wave.
A bit crushed.
Exactly.
Wave.
Thank you, Leandro. A bit crushed thing. And filter that heavily and see what comes out. So that's my next idea that I'm going to try.
You know what's interesting about this? Because the process of bit crushing or the process of reducing the bit depth does not change the frequencies. It only raises the noise floor because you have fewer bits to represent things, so it will get noisier. And once you introduce filters into the equation, I wonder what that will do, because we'll be filtering some of the noise that is introduced.
Yep.
Sounds interesting. I would love to hear more about this next time.
Yeah. Cool.
Chris used the bit crushing in order to showcase his dithers, because when you bit crush, you go and downsample, you go lower in the noise floor, and you can listen to what the dither is doing.
Because dithering is, you're kind of not filtering, but you're kind of massaging the signal in a very interesting way. Maybe that's a...
What you're doing when you're dithering is very specific. You're taking the quantization noise that would be introduced by the quantization step, by the bit crushing process. You're taking that noise and you're replacing it with your own noise. You're just completely getting rid of the original noise and you're replacing it with the new noise of your choosing. That's what dithering does to the signal. So that's why people like shape the dither to try and get the frequencies of the noise away from the range that we hear better and that kind of thing. So yeah, it sounds interesting. Looking forward to hearing more about this.
Yeah, cool. Oh yeah, that's another thing. The compressor. I was thinking of doing an algorithm, or sort of algorithm, for de-esser, and I was going to use the what did I call that? And again, it's the same idea from Chris. He uses the slew rate. Yeah, the slew rate for that. It might work, I'm not sure. So I've tried, I started doing a slew-based de-esser, and it didn't work as I intended, but I'm thinking of continuing on that. So that's another one.
Yeah, it's the D-Bass de-esser, right?
The D-Bass,
exactly.
Yeah, I think that was the first plugin that's how I learned about Air Windows.
All right.
Yeah, it was how I learned about Reaper too. It was from the same Podigy tutorial by Riley from Podigy, talking about how he edits podcasts, and he used D-Bass. And then I learned about Reaper and about Air Windows in the same tutorial. Isn't that great?
Nice.
Yeah.
Right. So with that, I think we are ready to wrap up this time for real, right?
Yeah.
All right.
Sorry to keep you.
No,
That's
don't
okay.
be sorry. It is great to hear from you, Bo. It always is.
Yeah.
So thanks for joining us, Bo and Fotis and Cwits. And thank you to everyone who was here on the chat with us. So Made, Jazz, and Ben, and Jack, and I think I got
Kulav.
everyone. Kulav, yes. And well, anyone else who's watching this, I appreciate you being here. I'm looking forward to seeing you all again in the next meeting of the study group 2 weeks from now. I don't know. Is it going to be like the holidays already? No, it won't be. It will be mid-December. So I see you in 2 weeks, and I see you again tomorrow for some data bending stuff. All right.
Cool.
Thanks, everyone. Bye.
All right. Thank you.
Bye, everyone.
Thank you.
Bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.